Okay, this is Screencast Unit 1, Screencast 3, so it's 1.3 on classification of matter. This will cover basically chapters 1.9 on density and 1.10 on classification of matter. So to start, let's talk about what matter is. So we have matter, right? Like that's everything that's not energy. And all matter has two characteristics. The first thing is that it has mass, and the second is that it occupies space. And that name for what it's occupying space, that's the volume. Right, we can measure that, how much space it occupies, by measuring the volume. Mass, as we defined earlier in the course, is how much stuff you have. So it has mass and it occupies space. And if we look at matter, we can divide it into three states. So the states, which you should be familiar with, states of matter are solids, liquids, and gases. For the purpose of this course, we're not going to get into the fact that there are other states like plasma and things like that. We're just going to go with etc. No Bose-Einstein condensate, right? That's another state. Solid, liquid, gas. Solids have a definite shape. This is how we know them to be solids. And they basically they have a definite shape and a definite volume. And if we nano a solid, we're going to show that its particles are very closely packed. Though we know they're not standing still, right, because they are vibrating. The bonds between them are so strong that they do not move. They have definite shape and definite volume. Liquids, on the other hand, have no shape, no definite shape, but they take the shape of their container. They take the shape of their container. And, but it does have a definite volume. So that gives us liquids. So if we were to nano a liquid, we would show that, they're kind of amorphous a little bit here. Maybe they're moving, little whooshies to show movement if you wanted. Okay, and they're taking the shape of their container. Gases, on the other hand, the third state we're going to deal with, have neither definite shape nor volume. Okay, so they're very free and they will fill the space of the container they're in. So if we were to nano a gas, we would show them very spread apart, very few particles. If they were moving, they'd be moving quite fast in general. Okay, so these are the three states of matter. Now, matter itself has different properties, and it's important for us to define those properties. So properties are basically characteristics that we can use to classify. We have properties of matter. Divide into two. We have physical properties, which are properties that have to do with characteristics, things that might be involved in a physical change. Those physical properties can be things like color, odor. Density is a physical property because it has to do with mass and volume. Hardness, if you're talking about a mineral or something like that. Solubility, if you remember that solubility is its ability to be dissolved in a solvent. Solubility is the ability to be dissolved in something like water, which we would call a solvent. Melting point and boiling point, which I'll abbreviate BP. These have to do with the physical changes that something can go through. So while I'm talking about melting and boiling point, let's talk about the changes between the states of matter. These are physical changes. So when we go from a solid to a liquid, that is called melting. Technical term here. These are vocabulary words. When we go from a liquid back to a solid, that's called freezing. When we go from a liquid to a gas, we have, lost my place here, boiling, liquid to gas, or evaporating, depending on the characteristics of what's going on. Okay, evaporation. We go from gas back to liquid, we have condensation. Two other changes that sort of skip that liquid phase, solid to a gas, is called sublimation. If you've ever seen dry ice, which is solid carbon dioxide that sublimates at room temperature. And then we have gas back to a solid. This is called deposition, DEPOS, deposition. These are physical changes that matter can undergo, okay? Physical changes. So the other kind of property that matter can have, other kinds of that matter can have, is called a chemical change, or chemical properties. Okay. Chemical properties are those that we measure, properties that are measured by chemical reaction. Okay, so in order to measure a chemical property, we're going to have to do some sort of reaction. Those properties might include reactivity. How likely is it to react with acid or base or other substances? Okay, that's one of them. Another chemical property might be, I'm trying to think of another one. Usually reactivity is the only one we can do. Yeah, that's about it. Reactivity with acids, bases, or other substances. So those are chemical properties. Do they react with metals? Do they react with things? Those are the chemical properties. And reaction, chemical reaction, is another name for a chemical change. Chemical change is synonymous with a chemical reaction. And that includes the rearranging of atoms. So if we rearrange the atoms within a substance, we have done a chemical reaction that is a chemical change, especially only if a new substance or substances are formed. Okay, so let's talk a little bit for a second about how we sort of classify matter and how we know what kind of change is involved, mainly because we may need to separate or isolate some sort of substance. And it depends on whether or not we can use a physical means or a chemical means to separate, whether or not we're talking about chemical properties or physical properties. So we start up here, and this diagram is very similar to, or almost exactly the same as the one on page 31 in the newest edition of the book. It's sort of a colorful diagram. You'll probably recognize it. So if we start with all matter can be divided into two basic categories. We either have mixtures or we have pure substances. And the way we tell the difference between those two is whether or not it has what we call variable composition. So if we were to scoop part of that substance up, if it looked identical no matter what scoop we took, it would be a pure substance. If we were to scoop the substance up and it looked different based on what part we took, that would be a mixture. So for example, a good example of a mixture would be cookie dough with chocolate chips in it, right? Or cake mix with blueberries or something like that, something food related. Salad is a mixture, okay? A pure substance is one where no matter what we take, we will always see the same composition. Sugar, for example. One particle of sugar looks like another particle of sugar. If I took a scoop of sugar out of the sugar dish, I would see that every scoop would have the same substance in it. It doesn't vary. But if I took a scoop of trail mix out of a dish, I might have more peanuts than M&Ms in one thing. So that's a good way to think of it. Trail mix is a mixture, hence the name trail mix, and sugar is a pure substance. All right, so pure substances can be divided into two categories as well. The first are elements, and the second are compounds. Now, compounds are made of elements. So the way to tell the difference between this is, are there various types of atoms? Okay, if there are various types of atoms, you have a compound. If there's just one type of atom, you have an element. And obviously elements are made of atoms. Okay, now over here in pure substances, these things, we can only separate them or get things isolated from them by chemical means. For example, let's say you have a pure substance, H2O, that's water. We cannot physically separate oxygen from that water. We would have to use a chemical means to separate that oxygen atom. Mixtures, on the other hand, can be separated by physical means. And I'll list some of those means in just a second. Some of those ways that we can separate mixtures. But it kind of depends on which mixture we're talking about. There are two kinds of mixtures. One is called a heterogeneous mixture, and the other is called a homogeneous or homogeneous. The prefix hetero meaning different, the prefix homo meaning same. So if you can visibly distinguish the parts of the mixture, it is a heterogeneous mixture. For example, a mixture of salad, right? If you have lettuce and tomatoes and cucumbers, that is a heterogeneous mixture. You can see the separation of those parts. A homogeneous mixture would be something like Kool-Aid, okay? Or lemonade that you make with the powdery mix, or Gatorade. When you put the powder into the water, it dissolves, but everything looks the same in there, right? But you know that there's red powder in there dissolved in water, okay? That is a mixture that looks the same throughout. So it gets a little complicated when we look at the difference between a homogeneous mixture and a pure substance. So really what you're looking at in a homogeneous mixture, especially something like a powder dissolved in water, is that there are various compounds in that homogeneous mixture, whereas in a pure substance, it's usually just one compound. Okay, so those are very sometimes hard to tell the difference between homogeneous mixtures and pure substances. But you'll be able to tell by whether or not you can separate it by physical or chemical means, and you'll just have to have a little more information. All right, so the chemical means of separation, we talked about those are chemical reactions. We might react it with an acid. We might run some energy into it, like electricity. For example, if we wanted to do electrolysis, split water, we would add energy, usually by electricity, and we would end up with hydrogen and oxygen gas. I'll show you an example of electrolysis tomorrow in class. We'll have some back in lab. That's a chemical means of separation because we've had to use some sort of chemical reaction or, something beyond a physical separation. However, physical separations one of them that's easiest is filtration. So let's say you've got a bunch of metal, you've done a chemical reaction, you've got a bunch of metal floating around in water. You can filter that metal out. Okay, that's a mixture because it's a mixture of those metal chunks and the water. You can filter that water out just by passing it through some filter paper. That's a physical means of separating. Distillation is one that works based on the differing boiling points. Different substances have different boiling points. So we can distill something by, for example, distilling a mixture of alcohol and water by evaporating the alcohol. It has a very low boiling point. So if we turn the temperature up to below the boiling point of water, the alcohol will evaporate. We can recondense it in another place. And we've now distilled that out using that physical property of boiling point. So that's a physical means of separation. A third one that you'll need to know is chromatography. And there are multiple types of chromatography. Your book mentions paper chromatography. That is something you've probably done before, where we take a piece of paper, draw a line in pencil, we put some ink dots on it, and then those ink dots smear up the beaker when we put it in up the paper. We put it in water. Okay, we'll look at that again. You have thin layer chromatography, which I'll give you an example of. And then there's also something called gas chromatography. All of these work on the idea that certain substances will travel faster than other substances. So it's a physical means of separation because you're depending on something's ability to move through a stationary phase. In paper, the stationary phase is the paper. In thin layer chromatography, it's usually some sort of silicate gel. Silicate gel is like a sandy, glassy gel. In gas chromatography, you're depending on sort of the polarity of the gas. Some gases are going to go through faster through this gas chromatography chamber than others. These physical means of separation are the three that you're going to need to know how to do for this class. So we're going to spend some more time together looking at these. That basically covers chapter 1.10. I would say in terms of density, we've done a lab related to density. Most of what is in chapter 1.9 has you doing calculations with density. Just remember that density is the ratio of mass to volume. That's an easy thing to rearrange. So I'm not going to spend too much time on density. It is an intrinsic property of something, meaning you can identify a substance by its density, just like you did in the lab.